Welcome to the Cosmic Pie Podcast, Season 2, Episode 15. I'm your host, Wayne Barkhouse, and here with me,
Robert Moore.
So, Robert, before we introduce our very special guest that we have today, we'll let people know in case they haven't seen our podcast before. We are broadcasting live from the campus of the University of North Dakota here in Grand Forks, North Dakota. We do have a live chat that's running, so if you have any comments you'd like to make throughout the podcast, or maybe you have some questions you'd like to ask us, please feel free to use that feature. And of course, as a disclaimer, anything that I say or Robert says is our own personal opinions and not necessarily the opinions of our department, our college, our university, our state, our country, our planet, our solar system.
I don't know, a planet we might
our
be able to
galaxy,
speak for.
our universe. We covered everything, I think.
Yeah.
That's the legal part of
That's
things.
the legal part of things.
Lawyerese, right? The lawyer aspect of things. Anyways, it's our pleasure to introduce a very special guest. He's been here before, coming all the way from Puebla, Mexico, the most famous Mexican astronomer since Guillermo Hero, and Omar Lopez-Cruz. Thank you, Omar.
Uh-oh. Can you hear us? Uh-oh, we can't hear you. Just a second. What's going on here? Okay.
Oh, we got you there.
We got you there. Okay, maybe not.
I can hear him. Say something, Omar.
Yes, thank you very much. Yes.
There, we had a little bit of audio issue, but it's worked out. So go ahead, Omar.
Okay, thank you. I think it was my. I thought it was my YouTube. I have to kill you. Yes, just a second. Hello.
Hello.
We can hear you.
We can hear you. Can you hear us?
Hello.
We can hear you.
I think.
Okay.
I fixed it.
Okay. So
it was my. Yes.
Okay, Omar, so kind of get things rolling here today. So last time we were talking, of course, we got into a lot of, reminiscing, I guess, for lack of a better word. And so today, maybe we could start off, if you could tell us, if someone who's not interested, deeply in astronomy, they maybe it's an amateur astronomer, or they're definitely not a professional astronomer. Can you kind of give us some highlights of astronomy in Mexico? Because some people may not associate Mexico with astronomy, but that's definitely not true. There's a lot of interesting things going on in Mexico related to astronomy. Do you want to kind of share that with us?
Yes, thank you very much, Robert and Wayne. It's a pleasure to be with you, back with you here here I am, Mexico. You're in Grand Forks. Yes, let me comment. I'll have an anecdote about this. There is a science fiction movie called Cygnus, and it's being shot at the Large Millimeter Telescope at 4,600 meters above sea level. This is the largest antenna for millimeter astronomy in the world. And very few people know that it is right in the center of Mexico. And this movie was taken to festivals, and this was told to me by the director. The movie was shown in sci-fi movies, festivals around the world, and they went to England, to the United Kingdom, and well, the story says that somebody goes crazy because they receive a signal from Cygnus, from the constellation of Cygnus, and people here began to act weird here in Mexico. And people act weird when you are at 4,600 meters, so it was hard to shot the movie there. But what people in the United Kingdom found most incredible wasn't the story, of course, was that you said, do they have telescopes in Mexico?
Oh, Lord.
Oh, dear. Do you have astronomers in Mexico? I said, so this view about the Mexicans with a poncho and a sombrero and sleeping is the view that most of the world have about us. I mean, we're thinking about common people, right? So
Right.
as scientists, you know that there are Mexican astronomers. We are part of the International Union, right? The Astronomical
Hmm.
Union. We are part of the American Astronomical Society. We go to meetings to the American Astronomical Society. Sometimes people come to Mexico for meetings and all these things. But that tell us a lot, Wayne and Robert, about the popularization of science and
Right.
the biases that we have in our minds.
Yep.
And this is a subject for another talk because those biases dominate the opinion and they're hard to get out. I mean, they're hard to go around. I'm just going to say this briefly. You and I have elections, presidential elections coming up,
Hmm.
and these views that are implanted in the public opinion, they last till
Right.
people begin to question. And it's the same thing here with the view of about us Mexicans that are lazy and uh, poorly educated. That is not, it's not totally wrong picture, but it's not the complete picture. So
Right.
when I went to North Dakota to become the endowed chair of the Benediction endowed chair of astrophysics, I was asked. I had to get permit from the U.S. Government to work in America, and they were very surprised to see first a brown skinned guy that was highly educated, that could speak English very well, right? Or at
Right.
least I tried. And this was totally against the view that
Right.
most of the people have about us Mexicans. And also we have a view about Americans, right? These are ones that we get here in Baja sometimes, right? They're not usually the typical Americans. But is we have as a compromise or a duty from us scientists, also with you guys, is to tell the people, the general public, what we do,
Right.
and that we are regular people, and then basically, you know, there's a few differences, but it's mainly passion, I would say, that set us apart. But we're not the only passionate people,
Oh
but we
no.
charge less. We don't make much money with our passion, but it's fine. That's we can go by,
Yeah.
right? So that's the anecdote. I mean, can you believe that? I mean, are there astronomers in Mexico? People. It was the most shocking thing. It's
Right.
like the most sci-fi thing for the public in the United Kingdom was Mexican astronomers.
Right.
Well, I mean, you think a lot of people they form opinions. People who certainly don't travel around the world form those opinions by watching movies.
Right.
You know what Hollywood produces. And when was the last time that you could remember a Mexican astronomer in an English movie made from Hollywood?
Never. Wow, no,
Never.
no. There is an astronaut. This
Yes,
Oh.
right.
guy, this guy, but he was educated in the United States. He's a Mexican guy.
Yeah.
He has a movie. It was this guy Peña who did the movie. Very famous in Mexico. He charges a lot for a talk, actually. I'll recall the name, but it's that is one of the very few stories that we can tell. And the other thing that I am very proud to tell you guys is there are Mexican astronomers working at the center, the control center for HST and
Right.
James Webb. And
Okay.
I'm very proud of them. Some of them are our graduate students from Mexico working
Nice.
there.
So that's a
We, such as Maria Peña, I called her the other time, and she was shy to tell me, Omar, did you say I'm not doing research, but I'm the support scientist for an instrument and blah blah blah. And I said, oh, I'm so proud of you.
Right.
I'm very so much proud of you because of you're breaking barriers. I mean, to get there, and it's the same for all the Latinos in or Hispanics, I should say, in America. When they get is there is another a Mexican an astronomer from Mexican origin who is at Goddard. and she's breaking through, and then I'm sure she will get a position soon. She's
Cool.
very bright and she's very enthusiastic and very proud of her roots. I just give me a minute. I will recall her name, but she's my friend on Facebook. But she's from San Antonio. Luna. It's coming. It's coming. Just give me a second.
it's
And I
that
would.
it's that
You got-
age thing, Omar.
That you get so much in your head.
Oh boy. Oh boy. Yeah, it's coming. It's coming. So I'm very proud of her too. Publishes everything she does, and then when she goes and give talks. She was at the meeting in United States. Oh, and she's doing great. And also from our side in Mexico, we recognize her, and she's been invited to deliver talks here in Mexico.
Cool.
Of course, her accent is marked by the English, so sometimes she struggles to speak in the Spanish. But anyways, is we're very proud of her because of this. That is a Mexican woman that is trying to get a position and doing astronomy in
Nice.
a very competitive world of the United States.
Yeah.
That's the one thing about science in general is a lot of times we focus on the problem and how we go about trying to solve a problem, irregardless of who's there, where they're from, what their backgrounds are. All of that is irrelevant in the sense when it comes to strictly understanding the science aspect of it.
Yep. We try anyway.
Yeah, it's like
I mean, it's a
everybody is equally able to conduct science regardless of where they're from in the world.
Right.
Her name is Laura Vega.
Okay.
She's at Goddard.
Got it.
And
Okay.
I send her regards, and I'm going to tell you that we are very proud of her, and it's true, Wayne. But the other thing is you cannot detach. I would say,
Yeah.
and we can argue about that, the personality of the scientist and the science.
Right.
In a way, it evolves like the zest or the passion that when you attack the problem. I mean, there are some people that they are just out of this world. We can talk about this guy von Neumann, right? No, he was a Martian. I mean, they said he was a Martian. I mean, that guy was so talented. I mean, the other time you were talking about Oppenheimer, but behind the bombs, there was this guy, von Neumann, Johnny von Neumann, a genius, out of this world.
Right.
And it was in other ways. This guy was a total, you would have he couldn't connect. I mean, I bet that he couldn't tie his shoes, his laces. I'm sure, but he could solve a big problem,
Right.
or see the world in a different way. But normal people like you and I, guys, we have to have something else aside from the talent. We have to have this passion or the thing that keep us going in the face of problems, and in the face of I don't like the word discrimination or whatever, or there are places that no Mexican or no guy from Nova Scotia has ever been, or things like that. So
Yeah.
or I don't know, Robert, you're from Mississippi, or where are you?
Originally from Mississippi and
Exactly.
and live in
I
South
guess so.
Louisiana as well. So yeah, who thinks of Mississippi and associates astronomy? So
Well,
our
there is
physics.
or no, but the scientists can come from anywhere,
Right.
right?
Anywhere.
I think the when when you're talking about trying to solve a scientific problem, that's one thing. But the other thing which really shows up, which that affects the culture or the society which we grow up in, is the actual opening up the opportunity for a very young person to become a scientist.
Right.
And that varies so much across this world. Some places it's highly encouraged. Other places, of course, depending on who you are and your background, you're discouraged. You're actually prevented from becoming a scientist in
Right.
some places.
And I want to mention that you mentioned something just to me that's really big and important, and that is passion. You got to be passionate about what you're doing, or else why are you doing it? you've got to find that motivation,
But
somewhere.
you see, there is this thing that I learned when I got to Canada, and there was this thing. Mexico. I mean, we're a macho-dominated society, these things. So I went to school, and 50% of the students were women, right?
Huh?
So, and none of us were told, not in my family, not in the school environment, told us or told the girls, the little girls, that they were not suit or fit to do science. Nobody said that,
Hmm.
and it's true. I mean, it was basically poverty, the big block that was preventing you from going to university. I mean, but it wasn't because you were a girl that you were told, you cannot go to school or you
Yeah.
science. You can. That was something. I mean, not in an open way. Many of my colleagues were told at home by their mothers and said, "Oh, you should study something else." But when I was in not engineering, not mathematics, not physics, you should become a teacher. That's what they were told at home, mostly women. But Sarah Seeger, I don't know
Yeah.
if you recall her.
Yeah.
Sarah
Yes.
Seeger is one of the best astronomers in the world, and I don't have to say that she's a woman or whatever. She's one of the foremost astronomers in planetary sciences.
Absolutely.
I was her TA, and I'm very proud to say that I was her TA
Oh,
in Toronto,
nice.
Yeah.
right? And she once told me that during an elementary school, the science teacher, I might have been like grade 6 or something, told her that science is not for you.
It's weird because
I,
you hear stories
I,
like that, and usually those stories are like back in the 50s, right?
Right. But
And
Sarah
even
Seeger,
like
yeah.
even Vera Rubin, there's documentaries about her,
oh,
and she said the same thing, that she was discouraged from being a scientist, right? And here's like a Nobel-winning potential scientist in her career. She didn't win the Nobel Prize, but she certainly deserved it.
Right.
And it's you think like that kind of treatment, at least in our society, was something that happened many years ago. But that's
now
not.
that
But that's not the case. There are
Yeah.
now
situations. Yeah.
I think we have progressed a lot, but Sarah is a child from the 80s,
Yeah.
and you should remember, Wayne, that Princeton University, the university accepted women to their graduate studies in 1971.
Yeah.
Oh, wow.
So,
Well, I'm going to take this moment to say anybody out there listening, you can be a scientist. So get out there and try. Study it, get passionate about it. You can do it.
Now, Omar, I'll just take a little
Yeah.
spin off in another direction. So you mentioned the
Yes.
LMT. Do you want to kind of
Yes.
talk about that and why it's so important to have that instrument,
Oh,
in the grand scheme of astronomy?
oh yes. You mentioned Guillermo Aro, and we talked about it last time. We began to modernize astronomy. We had, I mean, nobody knows that astronomy is useful these days, but astronomy has been very useful through time. Is of practical importance for going for sailing, for the harvesting, for all the cycles in nature. And one of the services for the industrial societies was time. The keepers of time in in Europe, in Mexico, in United States, were the observatories, the
Right.
astronomical observatories. Till we got, the atomic clocks, and then the business. We ran out of business, but we became important in other ways. And you might remember, Robert, the problem with longitude, and the problem with longitude.
Just keeping
And
time.
you should know that Edmund Halley played a very important role in getting the position of the stars from the southern hemisphere, going to that piece of rock called St. Helen in the middle of the ocean there, where they sent Napoleon at one time. But
Yep.
but it was important for commerce to know the position of the stars and try to solve the problem with longitude, because that's the problem. Latitude is easy; you just need to find the position of a North Pole star. But longitude, like east or west from Greenwich, or that time was Paris, you cannot tell that easily. They have
Right.
solutions like stabbing a dog in Paris, and then when the dog will bark they would take another dog on the boat on board. The dog will cry. They would say it's noon in Paris. Can you remember that? I mean, can you can you picture that solution? Well, they try it till there you. So in
That's K. That's
Mexico, we have.
Omar. I would call that canine entanglement.
K9
Yes.
entanglement.
Oh, now that I think about it, you might be right.
But
Well,
yeah,
so
yeah, keeping
this
time was
service
important.
is very important. It was very important because reaching the ports of Europe with the goods from the colonies was, I mean, the one who will get there on time or first will sell the goods, and the
Right.
rest will have to bargain with a lesser price. So it was very important to get there on
Hmm.
time, So navigation, the art of navigation was the 19th, 18th, and 19th century. It was a big thing. Astronomy helped, and there was an astronomer, always on a trained astronomer on the service of Her Majesty, and that's why they have Greenwich Observatory. It was for the imperial, and that's why when people get lost and say, "Well, what do the astronomers do? You keep on watching the stars all the time. What is the importance?" Well, it has been important, and still we have other applications for. And there is a full book by Neil deGrasse Tyson on accessory to war. It's called, where they explain all the instruments that we use in astronomy that can be used for other purposes, right?
Yep.
So we have detectors, the infrared detectors, ultraviolet detectors, gamma ray detectors. All of these things can be applied to war, and we don't do it, but there are some of us are doing it, mostly in the United States. Um, but it's very important that to associate astronomy with all what is the activities, the economical activities. So that's why we had an observatory to keep the time. It was in Mexico City, and then it was moved to Tacubaya, outside from Mexico City at the time. And then it came the revolution, and then after the revolution, we were thinking about everybody in the world was thinking about creating new countries. It was the Soviet Union at the same time. It was 1910. They were a little bit later, but we started revolutions in the 20th century, and then the products of revolution was to modernize science in Mexico, and that's why in 1942 Tonantzintla came out. And
Right.
then in Tonantzintla, we have the second largest in the world Schmidt camera. I told you about it the other time. And with that, Guillermo Aro discovered the Hervik Aro objects that the Soviets would call Aro Hervik. And it was because it was Aro the one who discovered them first. And then, thanks to the intervention of Rudolf Minkowski at Palomar Observatories, I was actually Carnegie, uh, Aro got the recognition. In the letter, he almost lost the
Mm.
how they call it, the naming the objects after him, but they allowed to add to the paper that Herwig published, describing these objects. As we told the other time, they were the jets shocking to the ISM, not right, the the medium, the interstellar medium,
The
and then
circumstellar nebula.
circumstellar nebula. Yeah, right, but they are shocking. So these are the places where the jets are pushing through. Um, and you can see them now. There are movies actually from HST that you can see the evolution in time of these things.
Yeah.
It's really interesting.
And I'm
And
glad you went
yes,
there because I was about to ask you if you could describe what a Herbig-Haro object was. So you just did a good idea. It's these young stars that have jets that are slamming into the interstellar medium, the ISM, and producing a lot of light and radio waves and microwaves.
yes,
So,
and they are really, really nice.
mhm.
But nowadays, as I said, with the exquisite resolution of HST, you can see the movement. Actually, the previous astronomers with photographic plates, they saw the moves of these jets. It's really impressive. So
So I can follow that
now,
up, Omar, if I can interrupt you for a second.
yes,
So at the end of every podcast, we always do like a quote or an excerpt from
Right.
somebody. And it just so happens that for this podcast, Robert, I guess you're thinking, well, I actually have an excerpt from Guillermo Harrow's paper on these Herbig-Haro objects. So I think this is a good time, instead of waiting till the end of the podcast,
Oh, okay.
to actually
Right.
actually read it now. So this
Okay.
is from Guillermo's paper that was published in the Astrophysical Journal in 1952.
Okay.
Okay,
Wow.
so for those who want to look, it's volume 115, starting on page 572. So here's what he says, and at the end of this excerpt is the part about the personal letters that you mentioned already. So, quote, in a recently published note, G.H. Herbig reports the discovery of 3 peculiar nebulous objects near NGC 1999 and gives the spectroscopic description of the 2 brightest. The writer, that's Guillermo, had independently discovered these peculiar objects, finding H alpha and the O1 line at 6300 angstroms and 6363 angstroms in emission, that's a key word, in the spectra of the 3. And then he's got a reference, a footnote that says, in personal letters dated May the 31st, 1950.
Wow.
So this is before George Herbig published his paper on these objects, which were written to doctors Shapley, Harlow Shapley,
Carlo Chapley,
and
yes.
Minkowski. That'd be
Yeah.
Rudolph Minkowski, right? The writer Guillermo pointed out the peculiarity of these objects.
Yep.
So it obviously in science we say the person that gets the credit publishes first, but if you go back in time, what really was publications? It becomes a little gray. In fact, people have sent letters to each other, and those letters sometimes are taken as evidence of being the first, if you want to timestamp it, who was
Right.
the first to notice something. So based on these letters to preeminent astronomers in the 1950s,
Yeah.
Harlow Shapley and Minkowski, Guillermo was first
Right.
in finding the peculiar nature of these objects.
It was a gentleman's game, I would say. I
Yes.
mean, it was based on respect, because nobody would recognize a letter as I mean, we're talking about the 20th century, right?
Yeah.
And
Right.
it was publication referee. Publication was the rule, but because these guys were all gentlemen and they knew each other, and there weren't that many astronomers in the world, and NSF, I don't know if NSF was in place, and you were not fighting for funding to get your stuff. So I mean, we can tell a lot of stories about the priority of certain discoveries in astronomy, and sometimes it gets really ugly.
Yes.
Otto and Herwig became really good friends, and Herwig had a great opinion of Otto through the end of his days. Herwig lived a long life. He was an astronomer in Hawaii, died, I think, entering this century, he was over 90.
Yeah, I actually met him, Omar, when I went.
You did, right?
Yeah, I went to
Uh-huh.
a Casca meeting. This would have been in the mid 1990s, just before I went to Toronto at Penticton in
Uh-huh.
British Columbia, and he was there, an attendant
Yeah.
of the meeting. So I got to meet him.
Tall, blonde guy, right?
Yeah, really
So,
tall. I remember gray hair, bald. But he died, I think, definitely 2000 and something. He passed away in, like Omar
He
mentioned, in
made
his 90s.
he made it into this century.
Yeah.
And Otto was a lawyer. I told you
Oh.
about it. by train. I mean, he was trained as a lawyer, but was trained as an astronomer by Barkhouse, one of the greatest astronomers in the 20th century. I mean, Barkhouse was, they say there is a book called "The Guy Who Sold the Galaxy," or something like that. And that was Barkhouse, the surveys on the galaxy and also the bug globules that you mentioned the other time, Wayne.
Yeah.
That's why they are connected. But the thing is, to the credit of Guillermo Aro, it was that he found new phenomena that didn't fit into the things that were known at the time.
Right.
So he said it's a nebula, but the emission lines are kind of crazy. He could tell that. And he asked for, support from the astronomers who had access to larger telescopes.
Right.
And that was the idea. The Schmidt telescope is a survey telescope, but you need the larger telescope. At that time, where the Palomar
and Wilson,
Wilson, those were the telescope that you had access, and they were very good friends. And we know about them. There is another story that I haven't told about another Mexican astronomer called Arcadio Poveda. Arcadio Poveda, very few people know that he applied the virial theorem for the first time to elliptical galaxies. It was Einstein who applied it to globular clusters. The virial theorem is a very powerful concept that tells you that when you have a system, a dynamical system in equilibrium, you can see how the interplay between the kinetic energy and the potential energy, and you can measure the mass out of that. So the first guy who, there was Einstein, and then then after Einstein it was Fritz Zwicky, who applied it to cluster of galaxies, who thought in terms of a gas made of galaxies. And then that is the idea, because the virial theorem comes from statistical mechanics,
right?
Not from astronomy. So,
we're having some audio.
Yes.
You were breaking up a little bit.
It was an elliptical galaxy, thin as a gas made of stars.
Right.
And he applied, and he got the mass, and that was called the Poveda method. And he said that he came into this idea by looking at the publications of Carnegie observatories, where they were getting the first spectrograph that were able to measure velocity dispersions. Can you imagine that there was a state of the art? Nobody could measure velocity dispersions of the stars in a galaxy before the guys from Carnegie observatories.
Right.
So he came with the idea. He published the result, but he published it in the magazine that Guillermo Aro had decided to publish all the results from the Observatory of Tenancintle, because it was expensive to publish, as it is right now.
It still is.
Robert and Wayne, it is very expensive to publish in the magazines with the highest impact. So Aro said, no, well, we're going to publish ourselves. And then Poveda was forced to publish in the Boletín de los Observatorios de Tenancintle y Tacubaya. It was a very poor publication, but it was, very good results. So the very first volume, the very first paper, was a paper by Aro, who doubled the sample of planetary nebulae known at the time.
Nice.
Identified with the objective prism of the Schmidt camera of Tenancintle.
Now,
it's just a...
Yeah, so I was just going to say, sorry. So Herbig, he actually just passed away 11 years ago.
Okay.
So he died in 2013.
Wow.
So it's
boy.
Yeah, that's amazing. Anyways, the other thing was, and you talked about the virial theorem and Fred Zwicky. And the closing remark on that, don't forget, is the fact that that's the first indication of dark matter in our universe and sizes of clusters of galaxies, right? There were indications a little bit before that with Oort and the motion of stars in our own Milky Way, but this is the first time we've seen that sort of phenomena, if you like, show up on those very large scales like the sizes of galaxy clusters.
Right.
Well, remember the paper by Scott Tremaine in the 90s? And it was in Scientific American that he said that the larger the system, the more dark matter there is, which for me, it gives me a lot of troubles. And it was in elliptical galaxies, you also have dark matter, but the mass to light ratio in clusters is huge. So it's the best place.
Well, look at Netta Bakal's work, right? Where they the mass and those large systems, that was going up. I mean, there was almost no end to it at some point, remember, before it plateaus.
Yes, exactly.
Yeah.
So it is so yes, Zwicky discovered when opened the door to a new world. But as I said, it was also Arcadio Poveda, who recently died, who applying the Virial theorem to elliptical galaxies discover a method to measure the masses for those galaxies. So we're
I'm just going to say, who would think to apply the statistical mechanics involved in gases and use stars as your gas particles? I mean, that's just wild to make that jump and say you can do this.
It comes from Boltzmann, and then in North America you have Joshua. What is it? What is the second last name? I'm talking of Gibbs.
Okay,
Gibbs is the one who in America introduced all these methods of statistical mechanics. Joshua Wheeler Gibbs is the name. And these ideas, is a very powerful picture of thinking of atoms in terms of little balls, and then making the association of thinking about galaxies as little balls when you're thinking about a cluster of galaxies that is about 3 megaparsecs across.
Right.
So then it works. But get this, the gas, and Wayne knows about it, and the people who know about clusters of galaxies, the gas inside, trapped in clusters of galaxies, the equation of a state is that of an ideal gas.
Wow. That's
because
crazy.
of the separation and because it's so rare, right? That the description is even better than anything that we can approximate on Earth as an ideal gas. It is in the space trapped in a cluster of galaxies. Can you imagine that?
That's crazy. No, I would never have imagined that.
I mean, some of the stuff, so Haro, using the Schmidt camera, the advantage there, in case people are listening, they don't really understand, that allows you to photograph in his time. Of course, nowadays we do electronic cameras, charge couple devices and so on. That allows you to photograph a huge area of the sky at once. So that if you're looking for objects that are small in number, that don't show up very often, you need to look over a huge area of the sky to pick up these kind of rare objects. So that's one of the main advantages of using the Schmidt, would be allow you to see some of these rare things. Now, Omar, I think Harold was involved in studies too, where he would look at, for example, very red and very blue objects, right? That would show up.
Oh, the very blue ones. That was a big thing. The very blue ones, people would do like take one picture in the, say, yellow, one in the green, and one in the blue, and then compare them. Because we didn't have much money to buy photographic plates, put the three photos in one plate. So he put the filter, the yellow filter, took a picture, moved the telescope a little bit, remove the filter, the same plate, and then put the other filter, the green one, and then the blue one. And then he will have 3 dots. And of course, the integration times were, and that's the smart guy, it's really smart. they were adjusted the integration time so that an A0 star will have the same colors in the three bands. That
Ah.
that's the kick.
And that's the
It's
heart
not
of,
that,
yeah, that's the Vegas system, right?
of course,
Yeah.
of course. So a star that would be, white, say in a sense, will have the images the same size. And that is really the stroke of genius, because you will develop the plate and it will have the same conditions all over the plate. And it would not be that, you develop more one. And it was a very capricious thing to do photographic plates. I regret
Uh,
it. I mean, it was horrible. Uh, I even, almost failed my master's degree. I turned off the lights in the dark room, and I have my box of, plates uh, open, and I I didn't have a detector anymore. So I hated the plates because they were not foolproof. I mean, astronomer proof. I'm not saying that all the astronomers are like myself, but
no, I get it. Yeah.
But Ado did that, and then it was a matter just to look at where the blue is, the point in the taken with the blue filter was darker or bigger, and that
Right.
was it.
And
And Ado was much better than anybody else.
And in
He
fact,
had the
so I was just going to say, in fact, some of those blue objects turned out to be not stars, but quasars.
Quasars with the
nice.
radio turned off.
Right.
With the radio turned off.
Quasar.
Radio
with the
quiet. Radio quiet.
Radio quiet.
Yeah.
Hey. And this is the big thing. And then I like to tell this story. There was another guy in Conancintla called Braulio Iriarte, a photometrist. He learned photometry. He was like Hamilton, a gambler. And he was sent to the observatory to become a decent person. So he became a photometrist. So
he saw the light.
As somebody who works with photometry mostly, I've got to say that might not be a decent person.
Yes, he not even saw the light. He measured it.
Yeah.
So he learned photometry from Harold Johnson.
Yeah.
And he went to, I think he went to Flagstaff, or somewhere in Arizona, and he measured some of these blue objects with a photometer. So he could, Aro just had a scale and say, this is very blue, not so blue,
Right.
not blue. So the very, very, very the bluest ones were really blue. And then, Señor Braulio Iriarte met Sandage. And Sandage has just missed the identification of quasars as very far away objects. That was the other guy. What is his name? Schmidt. Martin
Schmidt.
Yeah. Yes, Martin Schmidt got right that these were very high redshift objects. So Sandage was left behind. Nobody paid attention to him. But then,
well, didn't Omar, the little twist on that? It didn't Jesse Greenstein and Martin Schmidt actually took the information that was provided by Sandage. Sandage notified these astronomers of these peculiar objects, these blue-like stars they were finding that radio astronomers had picked up, and he puzzled over their nature, and it was Jesse Greenstein and then ultimately Martin Schmidt that recognized the high redshift nature of them. And then when they published their paper on the discovery of these quasars, they left out Alan Sandage from the paper.
Oh.
And in fact, So if you're talking,
I don't like.
No,
I don't like Greenstein. Greenstein was not a nice guy.
Well, put it this way: we began the podcast talking about the human nature of astronomers, essentially, right? This is where that shows up, right? Like we're humans that are doing this enterprise, right?
Greenstein was a very ambitious guy. He was the director of Caltech, right? The Caltech astronomy. And I don't think he got along with Sandage, but not a lot of people got along with Sandage. That is the truth.
But you did.
But
You want to tell that story?
oh yes, yes, I'm getting there. So,
Okay.
yes. Oh boy, yeah, it's still good. So, Senor Braulio Iriarte gives the position of the bluest objects that Aro had discovered. Sandage goes and measures 5 of them, and 3 of them turn out to be quasars with the radio off. And then he asked Braulio Iriarte to say, how many of these objects do you have? Oh, we have thousands of them. And then Sandage got all excited and wrote a paper that, with this new population of high redshift objects that supposedly were very massive, he could close the universe. And he sent this paper to Chandrasekhar. Chandrasekhar stopped the press and said, I'm getting more redshift of these things, and then they stopped. And I think it should have the issue of astrophysical journal should have been published on the 1st of May. It was published 15 days later, just waiting for the results, the latest results from Sandage. Sandage thought that he had solved the cosmology. He got the numbers, and with that, the problem of cosmology was solved. The destiny of the universe, we were going to, collapse again and keep collapsing and expanding and collapsing, which is just a universe that I like. I mean, but who am I to tell you that I like that? Because it's a very nice universe, right? We expand, we collapse, we come back again. We would make another podcast in another, another epoch.
Another version, yeah.
Another version. That now we will be, I don't know. I mean, it's somewhere else in another galaxy.
But as a physicist would say, Omar, though, you have to reset the entropy.
Yes.
There are problems with that idea, right?
I know. You have to spoil it, Wayne. But the Sandage was wrong, because it turned out, and everybody should remember this, you have to look at your sample and see what kind of object you have. Never think that you have a homogeneous sample if you select them in any ways. I mean, that you say by color, you by a spectrum or whatever, you always will have, a few outliers. So it turned out that most of the blue objects were white dwarfs, not galaxies, not quasars. And that was a huge fiasco for Sandage. And I think was one of the first biggest blunders that he faced. He resigned. He submitted his resignation to Carnegie Observatory after that. I mean, the shame was so big on him that he said, well, I'm not fit for this. I made a mistake. I'm a fool. And can you imagine a guy like Sandage? I mean, a really, really genius of a guy. And of course, the director, it was Babcock, Horace Babcock. He said, no, you have still so many things to do. So I'm not going to take your resignation. Right. Go on. And Sandage went on. And when I got to extragalactic astronomy, we have to go a little bit faster now. And Wayne, you also found all the papers written by Sandage on clusters of galaxies, on evolution of galaxies, on the H-NAT problem, on the classification of galaxies. Sandage was so, I don't know, amazing in the terms of the production that he would do. Only, he was so powerful that only very few people could collaborate with him, because he was just, a monster. Will produce papers, will go and classify everything that he found on his side. I mean, it was incredible. I mean, I wrote in my thesis, and Howard asked me to remove it. Monumental work, and I think I wasn't fair to the work of Sandage. And I mean, in the sense that I wasn't exaggerating, I was a little. So uh, I had to meet. I said I had to meet this guy. I find him everywhere, and I asked for a scholarship to go and visit Carnegie Observatory after I graduated from Toronto. I got a Fulbright scholarship to go to um, Carnegie Observatories in Pasadena and spend some time there. And of course, what I wanted to do, there was another guy there that I met. It's still good friends with him. It was um, um, Alan Dressler. It was the other guy,
Okay.
and Alan Sandage. And they not at the time when I arrived there, Sandage wasn't talking with anybody else. So I arrived there, and I asked for more money from Mexico, and they say, who is this Sandage guy?
Oh, no.
We don't do astronomy in Mexico.
Who?
Yeah.
I mean, it was, of course, it was, a committee at the National Science Foundation in Mexico that is called CONACYT. He was an administrator that, didn't want to give me the money.
Right.
So I said, I just, printed ADS, and I found his H number.
Oh,
Of
yes.
course, it was over 100. How many publications? Over 500 publications in, say, 2002 from Sandage. He was still alive there. And the H number was, like the impact. The citations, over 25,000.
Right.
It said, if you know anybody, in Mexico that has that CV, well, I gladly stayed, but I'm going to meet Sandage. So I went to meet Sandage, and the surprise was, and then we were talking about personalities here in this program. He was a sad person.
Mm.
I thought, I would be so happy with just a tenth of a production of Sandage and the impact.
Yeah.
And this guy was not a happy guy. Can you imagine that?
Why was
You
he
know, like,
sad, Omar? Did you figure it out?
well, because he thought that nobody respected him, and he was that that he wasn't allowed to do more discoveries. And he said, I mean, he might have been like 70 something back then, or 80s. I said, you've been such how do you call it, as such a powerful champion. And he got really mad at me, and he said, Omar, I still have things to discover. And even with the numbers that I have mentioned, he thought that his work was not sufficiently recognized. And,
Mm.
and I was very surprised. I mean, I think maybe people who are as smart as these guys think that they haven't accomplished that much. But as I said, any regular astronomer would feel humble. Just, I would say half of the production of science, half of Sandage, half of the impact
Right.
of what Sandage was. But in Carnegie, in Caltech, people were laughing about him because of a problem with HNAT.
Yeah.
Right.
Sandage was fixed with Hubble constant of 50 kilometers per second per megaparsec. And in fact, I went to a talk, and they were just taking the results at face value from COBE, or well, at that time, WMAP. They would say that the HNAT that they would get, it will be super Sandage. So it will be below 50. And
Oh.
everybody laughed. Everybody laughed in this colloquium that I was sitting at. I feel really sad for Sanders, right? I mean, said that that is science. Even if I like Sanders very much, 50 wasn't the right number, and
Right.
he was married to that number. And explaining the persona, the personality of Sanders, I think it was Howard. Yeah, Howard G, our supervisor, who said the most clarifying thing. It was that Sandage thought in his mind that he was writing masterpieces, papers that couldn't be challenged,
Ah,
papers that were definitive. And he was wrong there,
right.
plain wrong. Because in science, we don't have the final word, right? Somebody, a little guy, a little grad student with a new telescope, or a new detector, can come and
And
and do more, or and advance what Sanders has put out.
yeah,
And I think that was the thing that kept him unhappy. We were going to have a drink. We were going to. He was a heavy drinker. He's actually his breath was smelled like alcohol, but he was writing papers. Like I was so
wow.
surprised. And we couldn't. I mean, he had a rupture of the intestine, and he went to the hospital. So we never went to Del Torito to have some tequilas. But we had, we had agreed to go out and have some drinks. But then the way I got into his office was because he had become sort of a philosopher at the end of his days, and he was talking about hermeneutics, or is a branch of philosophy that talks about like knowledge and how we advance knowledge and how we come and take the concepts back and we evolve them. So that's why I knocked at his door and I said, I want to talk with you about hermeneutics. And he grabbed me and put me in and said, "Oh, nobody knows about hermeneutics here." So he asked me, and I sat down, and we had a great time. Two or
Nice.
three times I talked with him, and a few years later, he passed away.
Yeah.
But it is amazing. There are people who want to know a little bit better about Sanders should read "The Lonely Hearts of the Cosmos" by Dennis Overby. That gave me a lot of how do you call it? A lot of material to know about the personality of Sandage. And in the next time that we come together again, guys, I can tell you about Jim Peebles, because there is also a chapter in Jim Peebles is Canadian
Mhm.
and very well respected in Canada and very well known around the world. Nobel Prize winner, nice guy, very very nice guy, really sharp. He doesn't take BS. He's a really nice. So, but read this book. I don't know if you can. Dennis Overby, The Lonely Hearts of the Cosmos, is the book. I also know Dennis Overby. I met him at Princeton. He's also a really nice guy, and everybody will run away from him when he was writing The Lonely Hearts of the Cosmos. But Sandage, and Sandage is the main how do you call it, personage, or the main character in The Lonely Hearts of the Cosmos. It is a lesson I think that we should take, and everybody who's listening, like if passion can take us too far, it can kill us. I think
Yes.
is the order. So shine as bright as you can, but not too much because you're going to burn yourself. And so is I think that's the a way to measure things. But is thanks to these guys, we get inspired.
Right.
Thanks to Alan Sanders, thanks to Guillermo Aro, thanks to Arcadio Poveda and the people that we've been talking about today, we draw a lot of inspiration and do what we like to do and
Yep.
share. And I've been so proud today to be back with you, so happy and to share this time with you guys.
Well, I just want to say thanks to you, Omar, for letting people know that there is astronomy going on in Mexico and that
Absolutely.
there are astronomers
Yeah.
who are born in Mexico and are doing just fine in the
Yeah.
profession. So
Absolutely.
thank you very much,
Thank
Omar,
you,
for
sir.
this.
Thank you very much.
And if you wanted to get involved in astronomy, or for that matter, any other field related to science or in the arts, please feel free to come to places like the University of North Dakota, where you
Mhm.
can take classes or be involved in programs related to STEM and STEAM. So you include the
Steve,
arts
yeah.
in that.
Remember the arts.
That's right. We have both online and also on-campus courses that people can take. Our next podcast will be next Tuesday, May the 7th, same time, 3 p.m. Central Standard Time. I already mentioned our excerpt or our quote for today. So the one thing I will stress, though, is that, keep your minds open. While you're still breathing, always want to learn. Always challenge yourself to learn new things. So with that, thank you very much for listening.
And you did get a comment from a Taylor Valdez, Omar. I'm not going to bring out my little bit of Spanish.
Thank you for representing Mexico.
Yes.
Thank you very much. And come also to the students worldwide. Come to Mexico to learn astronomy too.
Absolutely.
Yes.
The Instituto Nacional de Astrofísica, Óptica y Electrónica, we are also exploring the world. From from the tropics, actually. From the tropics. It's nice.
And you don't have to shovel snow.
And you don't have to shovel snow.
You don't.
Broaden your horizons. Always look for different views. So,
Okay, thank you.
Thank you.
Thank you. Bye-bye.
Bye.
Bye. And goodbye, everybody.